So today we are solving this problem, check if parenthesis string can be valid. So a parenthesis string is a non-empty string consisting of uh, open and close bracket. It is valid if any one of the following is true, like either we have a close and open correspondingly, or we have already A and B. So A concatenated with B, where A and B are valid parentheses. Either we have in this way, like A and B are already valid, and then we have the bracket around them, or we have a already balanced A string and around them another bracket. So these three conditions are the one which said this is a valid string. Basically, in general, also if we have a closing and corresponding opening bracket, then that is these combinations are basically the balanced one. So you are given a parenthesis string s and a string locked, both of length n. So locked and s both are of same length, but locked had 0 and 1s. Okay, so for example, you can see it here. See, this is our string s and this is the locked. So what does it mean is locked has 0 or 1. So for example, this is the string and we want to make it balanced. So right now it is not balanced, right? But wherever we have a 0 index, this indicate that at 0 index we can change the parenthesis. So for example, here if I change this parenthesis like this, okay, and if I keep, and wherever is 1 we cannot change the corresponding one. So anyway, if I make this guy as reverse 1 and I keep here as it is, this is 0, but it is not creating problem, so keep both of them as it is. Now this guy is also 0, so I can change the I can change this as well. So let me change it like this and keep it as it is. So see here, we did the two operation. Wherever 0 is available, at that point we can change, if we needed, we can basically change those characters to the opposite of opposite bracket. Okay, so what we did when we changed the 0th, the one, this very first one, because it is 0 in logged at index, and similarly at this second last one, if we change the direction, we are basically getting a balanced string. So what we have to do is, based upon this logged values, we have to make the string balanced. This is what we have to do. Now this is what we have to do, and now we will go for that how to do it. Okay, so a general assumption is, like, all of us know that a string would be valid if has like equally number of closing bracket and equally is the corresponding opening bracket. Opening, closing, opening, opening, then corresponding closing, closing. So this is what happens. We have general assumptions, right? So what we can do is, we can do one technique here is, like, for if we go from left to right, we will look first of all that is there any orphan closing bracket. We will check it. Okay, so what we will do, we will go from here, from left to right. Okay, then what we will do is, we will keep two variables. One variable is like balance variable. Okay, for example, I am writing it here. Let's say we have two variable. One is balance variable, BAL, and another is the wild variables. Okay, wild is for anchoring for wherever we have 0. Basically on 0 location we can change according to our convenience, whatever is required. Okay, so we have two variable, val and wild. Now we are going from left to right. Let's go from left to right. So this is closing bracket. When we are going from left to right, closing bracket we are anchoring for -1. Okay, so see here, this is 0. So we are in balance, we are putting only those values which has 1, so the one which we cannot change. So see here, we are coming from here. So what is their first value? It is 0. That means we will increase wild by 1, so this will become now 1. Now we are at here, so this guy is 1, so this is 1, so corresponding character is the closing bracket, and for closing bracket we are anchoring as -1, so balance would be now -1. Okay, so yeah, now we are coming at here. So this guy is 0, so 0 1, where it will go? 0 1 will go to wild, right? So it will become now 2. Wild would be increased. Now we are coming at here, this is 1, so whenever we are encountering 1, we will go for balance. So this is the again a closing bracket, so this will become -2, because -1 plus -1, it will become -2, right? Now we are coming here, this one, so this is 0, so we will go here, wild will become 3, right? So at any point of time we will check that wild plus balance. At any point of time when we were traversing this, wild plus balance should be never go to negative values. So see here, when we were at very first location, this was 1 and this was -1, so it was 0. When we came here, it is 2 and it is -2, so this is also 0. When we are at 3, let's see, so we are at here at this location, so this is basically what, this is 0, right? So for 0 we already increased the wild. Now we are coming here, this is again 0, right? So we will again increase wild, so this would become 4, and this was kept as -2 here and -2 here, right, because it was not a 1. So now you can observe at any place we didn't find any location where it was -1. So we can guaranteed say that there is no orphan. Okay, orphan means for the closing bracket there is always a opening bracket. That is why we are getting this sum as the positive. 4 plus -2, it would become 2. So you can observe also here that whenever we are going, we summed to this guy and this guy, right? This gave us -2, right? But we have corresponding 0 and 0, right? So we can nullify those minus effect. So for that reason we found that there is no orphan when we are coming from left to right. Now similarly we have to also find when we are going from right to left, there should be no orphan opening bracket, right? When we are coming from left to right, there should be no orphan opening bracket, the way which we have done. So similarly we will do for that as well. Okay, so let me remove these things and we will go from right to left this time. Okay, so let me remove all these things. Okay guys, so I would be removing this all because now we will set everything to again 0. Okay, so let's set it with 0. Okay, so now we are coming from right to left. So see here, this guy is 0, so 0 would increase wild 1, right? So our wild would become 1, not 0, because we got the 0. So this wild would become 1 because this is a 0. Now we are coming here, this is also 0, so wild would become what? Wild would become 2 now. Balance is still 0, right? Here also it is 0, so it is sum is still greater than the 0. Now we are coming at here, so this is 1, so this time balance would be increased by 1. Remember, when we are going from right to left, this guy would be anchoring for positive values. Okay, so now first time we got 1, so anyway both are positive, so no problem. Now we are coming at here, this is basically what, this is 0, so 0 would be increasing our wild, so wild will come 3. Now we are coming at here, this is 1, this is closing bracket, so our this would become 2 now. Now this is 0, right? So 0 would make it 4. So during this as well we never found any valence plus wild equal to 0, right? Nowhere we find valence plus wild equal to 0. That means we didn't find any invalid thing. That means this guy, the opening bracket, is also not orphan when we are coming from right to left. So we check from left to right for the orphanage of closing bracket, and we check from right to left for the orphanage of opening bracket, and we didn't find any orphan. If we didn't find any orphan, that means we are fine. This is a valid string. This is a valid string, so we will return true. If there was any condition where valence plus wild was going negative, for example, let's take one example which will anchor for that as well. Suppose we had like this, suppose this was not 0, this was also 1. Okay, so what will happen? This would be when we were coming first time left to right, it would be negative, so this would be -2, and our build would be 0, wild count would be 0, so at that time this would be invalid if the locked was like this. Okay, so this is what we have to do. Let me show you my corresponding code for it. So see here, this is my code. So anyway, one more thing guys, so we have to first of all check the length of it, because this length should be always even, then only we would be having a possibility of having pair of close and opening bracket. If the length itself is odd, that means we will never find a balanced string. Okay, so first of all we need to check the length of it. So what I'm doing here, See, if it is an odd value, we are returning immediately false. Otherwise, what we are doing, we have created two variables, wild and valence. Now see here, I'm traversing from first left to right. Okay, now see here, I'm checking if logged at caret I equal to 1, then what I'm doing, if it is opening bracket, I'm increasing valence. Okay, or if it is a closing bracket, then I'm making it decreasing. Okay, now what we're gonna do here is, otherwise, if see here, we were checking only when this is 1, right? Otherwise, what will happen, if it is not 1, that means it is a 0, and 0 1 are the wild one which can be changed. So that is why I'm increasing the count of wild one, right? So, and then I'm checking at every place that if wild plus valence is less than 0 at any place, means when wild are lesser than the valence in the number, then I'm immediately returning false, because in that case we would never be able to balance it. So if we are having this condition, we would return, otherwise we will go to right to left. We are coming down here and have again set wild and valence, just like we did here, right? We were doing in the same way we did it here. First we go from left to right, then we go from right to left. So similar thing I'm doing here. Now this time coming from right to left. So see here, if it is 1, then we are making positive if it is a closing bracket, because we are going from right to left. So balance plus plus, otherwise balance minus minus. Inside only when it is 1, because for 0 anyway we are these are wild values, so we are increasing. Now again we are making same thing. If anywhere we are finding less than 0, means the wilds are less than this balance. Okay, that means we cannot balance them, then we are returning false. If nowhere we found a false, that means everything is fine, then we're gonna return true. So let me run it code. We are doing 2 pass solution. Okay, so just in 2 pass we are able to solve this question. So we are taking time complexity is O of n, and space complexity would be constant, because we are not taking any extra space. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.